Okay, so that was the last question that we had to do in this section. And this is homework number 98. Now, if you look on your blue sheet that I printed out for you, it's actually homework number 98 is something else. So Miss Tompkins must have just decided to change that question. So homework number 98 is in the workbook still, page 456. Numbers 13, 17, and 19. Okay, so those are the 3 questions that you have to do for this assignment. Alright, that's it for this chapter. That's it for trig equations. Hopefully you didn't think that that was too absolutely horrible. A lot of kids were a little bit confused once they got down to the end, but all you have to remember is if your value is positive, think about where sine, cosine, or tangent is positive, because most likely you're going to have an answer in 2 different quadrants. Take a look at your interval, because on the test that you're going to take, sometimes the interval is between 0 and 360 degrees, sometimes it's between 0 and 180, sometimes it's between 0 and 90. So underline that information in the question. Make sure you're double checking it before you move on. Just be careful, okay? And the last thing is, don't overthink these things. If you see an identity, replace it. If you don't see an identity, just solve it like a normal equation, okay? The last thing that I wanted to do with you today was go over the portfolios with you, because I know that Abby said that you finished all of your portfolios. So that was portfolios number 3, 4, and 5, which is awesome. If you have those done, that's excellent. I really, really want to get those in so that I can grade them and give you credit for it. So what I did was I went back through portfolios number 3, 4, and 5, and I just double checked to make sure that all of the questions in them are things that you are capable of doing, meaning you have learned them already in the chapters that we've covered. So number 3, everything in that portfolio assignment you should be capable of doing. If you have a question, feel free to ask me, but it's not like it's stuff that you never learned. Number 4, same deal. Everything in there you've learned before. You might have forgotten it, or you might need to review it a little bit, and that's what I'm here for, but you know, you're not incapable of completing portfolios number 3 and 4. Number 5, however, there are a couple of questions on there that you have not learned yet. And there are a couple that Miss Tompkins went over in class with people, so I'm going to give you the same benefit of the doubt. So if you could do me a favor, grab your final portfolio assignment right now, and I'm going to go over a couple of those questions with you. So this is the final portfolio, portfolio number 5. Okay, so numbers 1 and 2 you should be able to do no problem. That's algebra 2 stuff. Number 3, however, that one was a little bit difficult, so I'm going to go through the whole problem with you. Determine the coordinates of the center and radius of the circle whose equation is given. And then this is the equation that you're given. X squared plus y squared minus 4x plus 14y plus 28 is equal to 0. Now, you're supposed to figure out the center and the radius of the circle, and that's supposed to be the equation of a circle, except for you're probably thinking to yourself, the only equations I've seen for the equation of a circle look like this. X minus some number squared plus y minus some number squared is equal to the radius of the center of the circle squared. That's what the equation of a circle should look like. This is all mumbled and jumbled, and it's not in the correct form right now. So we have to go through and we have to fix this equation. So this is what I want you to do. I want you to get all of the x values written together. So I'm going to write x squared minus 4x. And I'm going to leave a little bit of a space in between the y's. So then over here, y squared plus 14y. And then the last thing that I want you to do, leave another little space, and I want you to move the constant over to the other side. So you're going to subtract 28 from both sides. So this is going to be a negative 28. Okay? Now, you see how the x parts and the y terms are written as a perfect square? So it's a binomial squared. We need to have binomial squares down here. So in order to do that, we have to use something that's called completing the square. And I know that you learned that before, but it's something that kids hate. It's something that they don't remember, and it's miserable. So I'm going to go through the steps with you to complete the square. First thing that you do is you take the b term right there, and you divide it by 2. So negative 4 divided by 2 gives me a negative 2. The next step that you're going to do is square this number. Negative 2 squared gives me a positive 4. So in my equation right here, I'm going to write positive 4. Now what I just did was I added the exact right term that I needed in order to write all of the x's as a perfect square. Okay, but I can't just add 4 on the left-hand side of the equation. I need to add 4 onto the right-hand side of the equation as well, so that everything remains equal. Now we're going to do the exact same thing for the y terms. You're going to take your b term right there and divide it by 2. So 14 divided by 2 gives me 7. 7 squared is equal to 49. So I'm going to add 49 right here. That's going to be the perfect number that we needed to complete the square, and I have to add 49 over here as well. Now I have perfect squares. All of the x values right there I can write as a binomial squared, and all of the y's right here I can write as a binomial squared. So let's go through and do that. How can I rewrite this as a binomial squared? This is actually x minus 2 quantity squared, because it's the same thing as saying x minus 2 times x minus 2, and then if I FOILed that, x times x gives me x squared, x times negative 2 is negative 2, x times negative 2 is another negative 2, 2 negative 2's give me a negative 4x, negative 2 times negative 2 is a positive 4. So you see how this is exactly what we have right there? That's why I can write this as an x minus 2 squared. Alright, and I'm going to do the same thing for the y's. Plus, what can I write as a binomial square to represent this? It's actually y plus 7 squared. And if you want to get a hint where I'm getting these numbers from really quickly, it's actually that number right there. So when you took the b term and you divided it by 2, you're actually finding that term in there that you need it to have. Okay? Is equal to, now I need to know what all those constants are equal to, so negative 28 plus 4 plus another 49, that is equal to 25. So now that equation right here looks a lot like this. Now we're used to seeing the equations of circles written like this, and if you have an equation written like this, then the center of the circle is positive h, comma, positive k, and the radius is this. Okay? So the center is, you pretty much take these numbers and you reverse the sign. So the question wants to know what the center and radius are. The center is a positive 2, negative 7, and the radius is the square root of whatever number is right here, and the square root of 25 is 5. Okay? So that was question number 3 on your portfolio that you needed help with. Number 6 or number 4 on the next page you should be able to do, especially after we just went through that stuff. 5, you should be good. Alright, let's turn to number 15 and get some help with that one. Number 15. How many minutes do I have left? Okay, number 15. What is the period of the function y is equal to 1/3 sine. Now this is also why I'm going over this with you, is because there's a typo on it. It says pi over 2. It's actually supposed to be x over 2. Minus pi, close those parentheses. And we're trying to figure out what the period is. Now there were 2 different words that a lot of kids were getting confused in that unit. There was period and there was frequency. Frequency in the English language means how many. So the period is how many curves do I see in the interval between 0 and 2 pi. And frequency is really easy because it's actually a part of our equation. It's whatever number is written with the x. Now this looks a little bit confusing because it's x divided by 2, but there's really a 1 right there. So the frequency, or the b term, is actually 1/2. Now why am I telling you that? I'm telling you that because the period, we have an equation for period which is 2 pi divided by b. So you actually needed to know what that b was in order to figure out what the period was. But period as a definition is how long does it take to see one curve. How long does it take for me to see one curve, or one full cycle? Okay, so that's the difference. How long does it take for me to see one curve versus how many curves will I see in this range? So if period is 2 pi over b, this is actually 2 pi over 1/2. So I'm going to multiply by the reciprocal of 2 over 1. Those are gone, and the period is just equal to 4 pi. That is the answer for number 15, which is choice D. Okay? Number 16 on the next page is kind of similar, but I think I'm going to stop this really quick and then start another video for you.